Hey guys, welcome to lesson 1.4. Today we're going to talk about equivalent expressions. Your aim in this lesson is that you can determine if expressions are equivalent by distributing or factoring. Now there's a lot of reading here, and I think it's really important we read, so we're going to read this together. The idea of equivalent expressions, or equivalency, is extremely important. It is the basis of many, if not most, of our algebraic manipulations. Now, algebraic manipulation means how we use algebra and the ways we go about it. So we really need to think about equivalency as being something we're using every day. Here's the definition of equivalent, and it's going to be part of your vocab when you're in school and have a flashcard. But let's take a look at this definition. Two or more algebraic expressions are equivalent if they have the same value for every value of the substitution. In other words, no matter what value you stick in for x or y or z or whatever the variable is, the two expressions come out equal. So no matter what value you pick, it should always be the same. I could pick 10, I could pick 15, 2, whatever I pick, something is equivalent if they're the same value at the end. So let's take a look at what this means with numbers. Okay, exercise 1. Consider the three expressions below. So here are the three expressions. You've got, this is your first one, this is your second one, and this is your third one. Those are your three expressions. By substituting in the values of x given, determine which two expressions are equivalent. So substitution, what does that mean? That means that you are plugging in. You're plugging in values. Okay, so we're trying to figure out which of the expressions are equivalent. So is 1 the same thing as 2? Is 1 the same thing as 3? Is 2 the same thing as 3? So we're trying to figure out which of these three expressions are equivalent, meaning that they come out with the same number. So in order to do that, we have to plug all of these numbers in. Okay, so I'm going to do the first column for you, and then you are going to do the other two on your own to save some time. So this first column says x equals 7. So I'm going to write 5 parentheses. Instead of the x, what am I going to write? I'm going to replace it with a 7 and evaluate. This is the same as saying 5 times 4, which equals 20. Okay, let's try plugging in 7 into here. 5 times, instead of x, I'm going to plug in a 7. I like plugging in things with parentheses, especially if it's a number by itself. You can also plug it in by just saying 5 times 7, that's okay too. Remember your order of operations. You have to do the 5 times the 7 first, which is 35, then your minus 3. So this is going to equal 32. Okay, now let's try plugging into the third equation. 5 times, instead of x, I'm going to plug in 7, and I'm going to use parentheses because that's my preferred way. Minus 15 equals, what's 5 times 7? 35. Carry over the minus 15, and 35 minus 15 is 20. Now I'm going to look at each of these three columns. Which two columns have the same number? Column 1 and column 2. This is not right. So far it looks like column 1 is equivalent to column 3. I need you to do the other 6 boxes of substitutions on your own. For the second substitution, you're substituting in 0. And for the third one, you are substituting in 1. So please pause the video and do the work on your own. All right, welcome back. I hope that was some good practice of plugging and chugging. You should notice that what two columns are equivalent every time. Column 1 is the same as column 3. Okay? Alright, so that's looking at things that are equivalent. This expression is the same as this expression, right? They're equivalent. So exercise 2 is now asking which property, the cumulative, associative, or distributive, justifies, meaning explains, or supports, what that word means, supports the equivalency, which is like saying the sameness, oops, sorry, let me try that again. The sameness of the two expressions you determined. So this is saying, well, is it the cumulative reason that they're the same? Is it because the associative property is the same or the distributive property? Well, what's happening from this expression in order to get to here? What's going on? Well, look closely. What happened to the 5 and the x? It became 5x. What happened to the 5 and the negative 3? It became negative 15, and you are using the distributive property for this. Okay, so if you wanted to show your work or explain why, you can say, well, hey, look, when I distribute, I get 5 times x minus 5 times 3, which gives me 5x minus 15, which is the same as column 3, right? Okay, moving on to exercise 3. Which of the following expressions is equivalent to 5 times 2x plus 1 minus 4? Show your work to justify your response, and then test at least one value of x to check your answer. Okay, so although this is a multiple choice problem, these directions are asking quite a lot. So the first thing I'm going to do, because I like to keep organized, and this might take some workspace, is I'm going to rewrite this. I'm going to say, okay, 5 times 2x plus 1 minus 4. So I'm just rewriting that thing, the expression. Now I'm going to try and start simplifying it. The first thing I notice is there's parentheses, so I can use what property? The distributive property. So I'm going to distribute, and I get 5 times 2x plus 5 times 1. And then what happens to this negative 4 here? Well, I can just drop it down, right? Just put the minus 4 down. I'm going to follow PEMDAS. I'm going to do a multiplication first. 5 times 2x is 10x, plus 5 times 1 is 5, and I'm just going to keep bringing that minus 4 down. 10x, 5, and negative 4. Well, I see that I can combine the 5 and the negative 4 to get 10x plus 1. Does this answer match anything on the left? Yep, it's answer choice 3. Is that all this problem wants me to do? No. Did I show my work? Yes. Did I find the right answer? Yes. Have I done the test yet? This right here? No. So I'm going to write test over here. And it says test at least one value of x. Does it matter what number we pick? No. That's the whole point of equivalency, is that I can pick any number in here, and this 10x plus 1 should be the same as 5 times 2x plus 1 minus 4. So I'm going to pick the number 2. So x equals, and let me use a different color for this. I'm going to test the number and let x equal 2. Okay, and I'm testing this equation, 5 times 2x plus 1 minus 4, and I'm testing my new equation, my new expression, 10x plus 1. But instead of x, I'm going to plug in the 2. So, we'll show this with color. So instead of x, I've got 2 times 2 plus 1 minus 4, and 10 times, and I'm plugging in 2 to this one as well. And now I'm going to check and see if they give me the same number at the end. So let's do order of operations. 2 times 2 is 4. So I carry down all that. 5 then times 4 plus 1, that's 4 plus 1 is 5. Multiplication, 5 times 5 is 25 minus 4. 25 minus 4 is 21. So I get 21 over here. Let's see if I get 21 over here. What's 10 times 2? 20. And what's 20 plus 1? Awesome. They both work. So my answer of 10x plus 1 is correct. This is an amazing skill that will help you on the Regents to check your work, is just to pick any number. Could I have picked something other than the 2? Could I have picked a 3 or a 4 or a 5? Sure, I just picked 2 because it's an easy number to work with, right? You could have picked any other number, but 2 is an easy one to work with, okay? All right, exercise 4, we're going to try again, but we're going to try with a little bit of a trickier problem. Now, I know this looks a little scary with all of these parentheses and numbers, but we're going to do it the same way. But let's first read to make sure that it's kind of the same problem. Which of the following expressions is equivalent? What does equivalent mean again? It means the same to 4 times 3x plus 1 minus 2 divided by 2 minus 5. Again, looks scary, but we're gonna work through it. Again, show your work by thinking carefully about order of operations and the properties you've learned about. And finally, check your answer. So it's the same as the last problem. So if you want to try this on your own, I highly recommend you pause the video, try this problem on your own, and see if you can simplify and check your work. So go ahead and pause now, try it on your own. Okay, so I've rewritten my expression, and now I'm going to start simplifying it. So the first thing I'm going to do, PEMDAS, is I'm going to think about these parentheses, and I'm going to distribute. So I'm going to have 4 times 3x plus 4 times 1. Bring down the minus 2, divide it by 2, and minus 5. I'm a firm believer of doing things one step at a time. Now I've got this thing up here above the 2, and I'm going to work on this. So 4 times 3x is 12x, plus, what's 4 times 1? 4, and then minus 2, carry that, over 2 minus 5. Let's keep taking a look at this numerator here. I can see that I can do the 4 minus 2, and get 12x plus 2. Again, divide by 2 and bring down the 5. So if you notice, every time I've done a step, I've just brought down the 2 and the 5, right? Well, now if I remember distribution, I can also distribute by dividing, right? So I can take, I'm going to use a different pen to show this, I can combine the 12x and the 2, and the 2 and the 2, to give me a distribution of division. So I'll have 12x divided by 2, plus 2 divided by 2, and again, I'm just carrying down that 5. Okay, if you're running out of room, we can go over here. What is 12x divided by 2? 6x, because 12 divided by 2 is 6. What's 2 divided by 2? That's a 1, and bring over the negative 5. Finally, carry down your 6x and combine the 1 and the negative 5 into negative 4. Is that an answer choice on the left? Absolutely, it's answer choice number 4. Now how do I know this is right? Well, let's do your check. So we're going to check. And again, I like picking the number 2, so I'm going to say that x is going to equal 2, and I'm going to plug in both to both equations. I'm going to make a little separation here so I keep good track of my work. I want to stay organized, so I don't want my work on the left to mix with the work on the right. So I'm going to rewrite the original, 4 times 3x plus 1 minus 2 over 2 minus 5. And I'm checking my new expression, 6x minus 4. And now wherever I see x, I'm going to replace with a 2. So I have 4 times 3 times 2, not x anymore, plus 1, and then carry all of that down. And now I start using PEMDAS. 4 times 3 times 2 is 6. Let me scroll down a bit so I have some more room. 4 times 6 plus 1 is going to be 7. Notice I'm doing one step at a time. 4 times 7 is 28. Carry down the 2's. 28 minus 2 is 24. 24 divided by 2 is 12. And 12 minus 5 is 7. Let's hope I get 7 when I check it back up here. So now I'm back onto this one, and I'm plugging in a 2. 6 times 2 is 12. Minus 4 is 8. So I have made a mistake somewhere. So let's check my work and make sure that I've done something wrong. So I plugged in my 2. 3 times 2 is 6. 6 plus 1 is 7. 4 times 7 is 28 minus 2. Oh, there's my mistake. Look at that. What's 28 minus 2? 26. So I messed up. 26 over 2, and then I can do this. 26 divided by 2 is 13 minus 5, and 13 minus 5 is 8. So this is why checks are really important, and this is why being careful and making your steps neat and organized are important. Because notice I could go back to each of my step. Look at all these steps I had. I could go back to each of these steps, this one right here, this one, this one, this one, this one, and this one, and I could see my progress. If you're not making sure your work is organized and clear, you're not going to know where you made a mistake. And I didn't do that mistake on purpose, by the way. That was an accident. My intention when teaching you this was to do it correct the first time. But I think it's really important that you see that even teachers can make mistakes. But I can go back and find my mistake because my work was so organized. So please, when you're doing your work, yes, this takes a lot of space on your paper. You may need loose leaf, right? You may need scrap paper to do this. But it's really important that you have your work neat and organized. Now I know for sure that my answer is correct because they both gave me 8, so I've completed this problem. Okay? The final part of this lesson, and this is called factoring, and we're going to briefly go over this. This is going to come up later in the year, but I want to introduce it now. Is something we do where it's the opposite of distributing. So let's take a look. Exercise 5. Which of the following expressions is equivalent to 10x plus 15? Explain how you made your choice in the space provided. Now something you could do here, and this is a good strategy, is you could go through each of these problems and distribute and figure out which one's right. Right? This is going to be 16x plus 26. This is going to be 10x plus 15. This would be 25x plus 15. And this would be 10x plus 50. Which one matches what we want? Well, it looks like number 2. Now that's one way to do testing, where you just go through all the answer choices and figure it out. The other way that I think we should talk about is a logical way, where I have 10x plus 15, and I'm thinking, well, what do 10 and 15 have in common as a factor? A common factor. They each have a 5 in them, right? What times 5 gives you 10? 2. What times 5 gives you 15? 3. Right? This is a logic progression. You're thinking logically, and it's a skill that a lot of students struggle with. Right? You're undoing distribution. So this is called factoring. And I want us to think of factoring as reverse distribution. Okay? You're basically turning addition into a product. So factoring is the process of writing an equivalent expression as purely the product of other expressions. Okay, see, here's where the product is. It's 5 times 2x plus 3. It's a product. So if we take a look at exercise 6, here are some addition problems that we want to try and turn into a product. So when I look at A, I'm going to think of what do 6 and 21 have as a factor. And I think, okay, well, 6 and 21 both have a factor of 3. So I'm going to write down a 3, and then think about, well, what does it take to get a 6 from a 3 when I multiply a product? Well, it's going to take a 2. Okay? What times 3 would give me 21? A 7. Again, we're thinking logically about this. This is a tough skill. Here, I've got a 2 and a 10. What's a factor they both have in common? They both have a factor of 2. So I'm going to take out a 2. Now, careful here. If I take out a 2, I still have a negative in front of that 2. So this is going to become negative, just the x. It's like having a little invisible negative 1 right here, right? 2 times negative 1 is negative 2. And what times 2 gives me 10? A 5. We can rewrite this without the 1 and just put negative x plus 5, because this is like having a invisible 1 here. And finally, the last one, try on your own. I know this is tricky, but give it a try. Think logically of how you can turn that 14x plus 14 into some sort of product. So pause and try it on your own. Okay, hopefully you see that they both share a factor of 7 or even a factor of 14. So I could do this 2 ways. I could take out a 7 and say that this is 7 times 2x plus 2, because if I distribute, I get 14x plus 14. Or I could just take the 14 and say x plus 1, because 14 times x is 14x. 14 is 1 times 14. So really, there are two answers here. Right? This answer and this answer. Again, if this is something you're struggling with, and after hearing this lesson you say, I'm not sure what's happening here, please come to Ms. Vasquez, to Ms. Samaru, or to me during class. That's what class time is for. That's why we are here. So good luck on your fluency, and I'll see you at lesson 1.5.